When preparing the model to be printed, there are several factors to take into account before sending the file to the printer. Part orientation is one of the most critical aspects of achieving a successful print, which means minimizing overhangs on the model and making sure support material is in place. SLA parts may need to have a drain hole included. That way liquid resin isn't trapped inside the part. The amount of infill or solid material also greatly affects the part, as well as the desired wall thickness if the part isn't entirely solid. Adjusting scaling will also ensure that parts are sized correctly and can fit together. Lastly, the smoothness and finish quality are determined by a couple factors such as material thickness and adding any post-printing procedures to polish off the final design. With both FDM and SLA printers, orienting the part correctly is critical to achieving good results. With a part printed on an FDM printer, minimizing the number of overhangs will ensure that the layers will correctly adhere to one another, and the geometry will be built correctly. Typically, anything more than about 55 to 60 degrees of overhang will require support material to keep the layer from collapsing. This would cause a layer to disconnect and potentially a print failure. Here I'm using Ultimaker's Cura software to prepare the model for printing. To orient the part, I want to make sure the overhangs are minimized and that the footprint is as large as possible, especially if it's a flat surface. This means I need to rotate the part so that this face is parallel to the build plate. Then click on the Lay Flat button to make sure it's laying directly on top of the build plate. And use the Move tools to position it near the center. In this orientation, notice that the overhangs have been minimized, and the largest surface is flat against the build plate to make the largest footprint. With SLA, it's also important to consider how supports will be added, but not as critical as with FDM. There's also one important feature of printing SLA parts. If you're printing a part that is hollow, there should be either a natural drain hole so the part doesn't trap resin inside, or you should model one in such a way that resin won't be trapped in a cavity in the part. Here I'm using the Formlabs Preform software. Orienting a part in the software can be a very simple process. If I click on this icon, one-click print, the software will automatically orient the part to the optimal angle and position, followed by generating supports where necessary and calculating the layout. Notice that the part isn't flat against the build plate. If needed, these three steps can be manually adjusted to your preference. I can click on any of the icons, such as the orientation options, and make adjustments as needed. This is the same for the supports, such as adjusting the density, or adjusting the layout by dragging this icon to position it on a different area of the build plate. Next, I'd like to talk about the concept of infill, which refers to how much of the part volume is considered to be solid. The more solid the part is, the more rigid it will be, but it will also consume more material and time. Often the infill isn't solid material, but is created using internal structures that act like a solid. The Slicer software can automatically incorporate this, removing the need for you to incorporate this into the 3D model. For parts that need to function without breaking, a solid infill is ideal. If a part is non-mechanical or doesn't have to sustain external loads or pressures, you can reduce the infill down to the 10 to 20% range to save time and material. Another key aspect to consider is determining the part's wall thickness. The wall thickness affects multiple aspects of the printed part: strength and durability, amount of material needed, how long it'll take to print, and how refined the finished part will look. However, keep in mind that this only applies to parts that have less than 100% infill. Most slicer programs will also let you define the number of layers a part will have before it begins to create the infill. In FDM printers, wall thickness is typically set as a multiple of the size of the extruder nozzle opening. One of the key steps in creating a correctly sized part is adjusting the part's scale. Sometimes a printed part will shrink slightly as it cures, particularly for SLA printed parts. To account for this, the slicer program can be used to scale up the model by a few percent prior to printing. You don't have to account for this in the modeling software. In addition, if you're printing parts that fit together, such as a bolt going through a mounting hole in a part, you'll need to make sure that the part going inside isn't too large. So scaling the parts accordingly will help make sure the parts fit properly together. Scaling down one of the two parts will most likely take care of it. With all these considerations in mind, it's important to adjust settings to achieve the finished quality you're looking for. Because 3D printed parts are created in layers, the layer height has a big effect on how smooth and refined the finished part appears. Thinner heights will produce a smoother part, but will drastically add time to the total print time. If a very fine finish on a part is necessary, post-finishing of the part should be considered as a solution since it will keep the print time and material consumption low. This can include sanding, painting, and polishing.